We'll start today's lesson by going over your warm-up. Anyone know how I should start the first one? Yes, ma'am.
Distribute the 3.
Distribute the 3. Good. So I have 3x plus 7 equals 3x minus 12. The next thing you'd probably want to do is get your x's together. What happens when you try to get your x's together? They cancel out. You are left with 7 equals negative 12. Right here, you have to ask yourself, is that a true statement? No. So what is the solution? No solution. Okay, so you can write the empty set symbol, or you can put NS for no solution. So again, if you get something that's not true, that's when it's no solution. Let's look at the second one. Some of you can probably guess what's going to happen here. Let's get our variables together first. You can combine like terms on both sides. And then what happens on this one when you get your x's together?
0.
Yeah, they cancel out, right? You get negative 9 equals negative 9. Or if you added 9 to both sides, you'd get 0 equals 0. So is that a true statement? Yeah. So do you guys remember what the answer is here? All real numbers. Good. You can write out the words all real numbers, or you can use this symbol. That's the real number symbol. Or you can say all real numbers. However you choose is fine with me. Any questions on these? Today we're doing 1.6. Like I said, we are skipping 1.5. We will come back to it at the end of this week. This is all about linear inequalities. Here are the inequality symbols. Your homework last night, if you did it, actually covered a lot of this. So if you know this or feel like this is too repetitive, you can kind of skip writing this in your notes. But these are important to know. This first symbol is the less than symbol. If you say x less than 4, that does not include the 4. That's why we leave an open circle on the graph. This is the less than or equal to symbol. So if you would say like x less than or equal to 4, 4 is included. That's why this one, the graphs include a closed circle. Same thing down here. The greater than symbol does not include the number we're talking about, so we use an open circle. With the line under it, that's greater than or equal to, so we do close the circle in. I'm sure you were told in your younger years that the big mouth eats the bigger number. Still holds true, just kind of juvenile. I'm sure you guys have seen these symbols before. Any questions on them? To you. But just really quickly, these are the basic steps for solving inequalities. We follow the same rules that we do when we're solving equations. So get rid of the multiplying and dividing first, then get rid of the adding and subtracting. We do that using inverse operations. All those things are still true. This is the major difference. If you multiply or divide by a negative number, you have to flip the way the inequality is facing. Anytime you flip it or switch its direction, if it was underlined, keep it underlined. If it was an or equal to, it should still be an or equal to. So just be aware of that. That is the only difference. What are your questions on this? So for example, 1. How would I start, or where would I start? Yeah, add the 5. So now I have 2x greater than or equal to 18. Next step. Divide by 2. Great. X greater than or equal to 9. That is my solution. So I want to show on my number line everywhere where x is greater than or equal to 9. So 9 would be right about here. I am going to use a closed-in circle because it is an or equal to. And then numbers that are greater than 9 are to the right of 9 on the number line. Now, I allow you guys to do very simple number lines in here. I only want 3 things on your number line. I want 0, I want the number we're talking about, and I want its opposite just to keep things kind of balanced. So those are the only things you need on your number line. You don't need little tick marks in between or anything like that. Keep it simple. What are your questions? Anyone have an idea where we should start on this one? Distribute. Good. So I have 4 plus 3 minus 6x greater than 37. All right, I have some like terms, so I'll just turn that into 7 minus 6x greater than 37. From there, I would subtract 7. So I have negative 6x greater than 30. This is the magical step. Be ready. I'm going to divide by negative 6. What do I do when I divide by a negative 6? Switch the symbols. So now it's x less than negative 5. Pretty cool. Again, on your number line, all you need is 0, the number we are talking about, and its opposite. Is this going to be an open or a closed circle at the negative 5? Open, because negative 5 is not technically part of our solution set. And then when I go to the left of that or to the right? To the left. My solution is x less than negative 5, so I shade to the left. And I use an arrow to show that it's all the way to the left forever and ever. What are your questions? All right. Example 3. This one starts a lot like the last one. We got to get rid of those parentheses first, so I'm going to distribute. I see some like terms over here. All right, now it gets exciting. What am I going to do? You could add 5. I like to get my variables together before I touch the rest of it. So I'm going to subtract 4x. If you wanted to add the 5, that would be fine. You'd get the same thing, hopefully. I am ending up with negative 5 greater than or equal to 1. So this is just like the warm-up. You need to decide if that is a true statement or a false statement. Is negative 5 greater than or equal to 1? No. So what is my answer? No solution. So you could do the empty set symbol. You could say no real solution. You could put NS. Really up to you. What are your questions on this? If the direction said to graph, you would simply draw a number line with nothing shaded in, because no part of that number line will make this equation true. What are your questions? For number 4, where would I start? Distribute. Good. Similar to the last couple. Some of you may see the problem already, but when you go to combine your variables, they're all going to cancel out. This time I'm left with negative 3 greater than negative 10. Ask yourself, true statement or false statement? True statement. So you could say all real numbers, or you could put the real number symbol. However you choose. I will tell you what you cannot do. You cannot stop right here and assume that I know what this means. Okay? You need to take it one step further and either say all real numbers or no solution. If it said graph, your graph would be a number line completely shaded in. Everything on that number line is a solution here. Those are all real numbers. What are your questions? Okay, so here's just a little background information on compound inequalities for you. Any questions? Yep. Yeah, I'll give you guys a second to write this down. We will talk more about the graphs and what it means to be an and or an or statement on the next slide. So if you're feeling like it's still kind of up in the air, it's fine. We will get to it. All right, this slide holds what I consider to be the more important information about compound inequalities. Anytime we have an and statement, we are looking for something that makes both inequalities true. So to make both inequalities true, it's going to be the area in between the two numbers. Okay, and again, when we do examples, this will become a little more clear. If it's an or statement, that means it makes one inequality true or the other inequality true. So those are usually ones that are facing away from each other. It'll be less than some number on the left, greater than some number on the right. Occasionally on the ors they will overlap, then it'll be all real numbers. But for the most part, ands go towards each other, ors go away from each other. And again, you still have to pay attention to the open circles or the closed circles. On this slide, they are all written as open, so we know these are not or equal to statements. But again, ands go towards each other, ors go away unless they're special cases, and we will discuss those too. Any questions? Like I said, compound inequalities are essentially just two inequalities put together. Here it's an or statement, so we are going to graph both solutions. Remember, when it's an and statement, you only graph the overlap. So for this one, basically you're going to solve them separately and put them on the graph. I'm going to separate my workspace just to distinguish which problem I'm working on. The first one we distribute, we get 6x plus 12 greater than or equal to 24. Just like an equation, I would subtract 12. I would divide by 6. So x greater than or equal to 2. That's only half my solution though. Or, and then whatever I get on the other side. Over here I am getting 5x less than or equal to 5, which is x less than or equal to 1. So I'll put that down here in my solution. Box it in. What are your questions so far?
So that's our full answer.
That is it. Typically you'll see the less than one written in the front. So the solution in the back of your book would probably look more like this. However, I will accept either one. They mean the same to me. Now I have to graph it. So for OR problems, you essentially just graph them separately. I want to find 1 on the number line. I want to have a closed circle on the 1. And I want to shade less than, so that is to the left. I also want to find the 2. Close in my circle on the 2. It's greater than, so I go to the right. So you can see why these typically face away from each other. So your solution is this, or this if you choose not to rewrite it, and the graph. What are your questions here? I said earlier, and problems are typically written as one big long inequality with 2 places where you'd see a less than symbol. I actually prefer these over or problems because you can do it all at once. Instead of breaking it up into 2 separate problems, we can just take care of it all at once. You have to think of this as sort of having 3 separate sides. So if you look in the middle, to get x by itself, you would start by subtracting 1. So you can subtract it from the middle, you can subtract it from the left, you can subtract it from the right. If you want to do it all at once. I'll show you how to do it separately in a second, but I like to just take care of it all at once. So this would be 3 less than negative 3x less than 6. Next, to get the x by itself in the middle, you divide by a negative 3. So I'm coming up with negative 1. What do I do with the symbols anytime I divide by a negative? Flip them. Same thing applies on compound inequalities. Now, I told you on the ORs, it doesn't really matter if you want to put the smaller one in front. I would recommend it. That's the way the book will do it. That's the way I will do it. On AND problems, you absolutely have to rewrite it with the smaller one in the front. So you need to rewrite it with the negative 2 less than x less than negative 1. ANDs are always written using less than symbols. Okay, I could tell that some of you were not a big fan of the doing it all at once. That's fine. If you don't want to do it all at once, here's what you would do. You would set up 4 less than 1 minus 3x. You would solve that inequality. Then you would set up 1 less than 3x, or sorry, 1 minus 3x less than 7, and you'd solve that inequality. And then in your solution, you'd put the word and in between them. So if you want to break them up, you can. This is much quicker. It's a lot more concise, and it gets you a kind of a prettier answer over here. So I would recommend this. If you are not a fan, break it up. Just kind of forget about the less than 7 at first, then forget about the 4 less than second, and go from there. Any questions on that? Either way, you do have to graph it, so we would go to -2. It's going to be an open circle. It would go to the right, but be careful because remember, we're only concerned with the overlap. So next, locate the -1. Again, an open circle, and then the overlap is the space in between them. And it's easy to see over here when you use the less than symbol. It's basically showing that x is in between these numbers because it's greater than the first one and it's less than the second one. So this is a nice way to write this solution for an and problem. What are your questions here? All right, here's your homework. Again, it's written on the green sheet. This is section 1.6. So find that on your green sheet or just copy it off the board. It's page 45. It's only 25 to 47. You did the first part of this up to 23 yesterday if you did your homework after the quiz. So you kind of have a head start on this one. Just start on 25 to 47. Any questions? Thank you for pointing that out. Yes, this assignment, odd.